All right, it's 3:20, so we'll go ahead and get started. So I'm Chris Lindgren. This is Mike Dorman. I'm with GoDaddy. Been there for 6 years now, pretty much since the beginning of our OpenStack cloud deployment. You're in the don't repeat our mistakes talk, so give a little history of OpenStack at GoDaddy. So in 2013, we pretty much started with a proof of concept running Habana. That basically started out like dev and test instances, and quite quickly, probably within 6 months, we had a couple people running in production. So our proof of concept cloud quite quickly became production cloud, upgraded to Icehouse. Around 2014, we also did the upgrade to Cells v1 and also Kilo. Around 2015, we had an effort called OpenStack Everywhere, which I guess you'd really just call it OpenStack First, which is pretty much any new server capacity would try to go to OpenStack first unless you had some sort of reason why it couldn't, and then you'd have to basically put an exception in. And then we've pretty much been stuck on Liberty due to a variety of reasons, none of which is related to actually being able to upgrade. But right now we're working on doing containerization of the OpenStack services and redoing some of our deployment tooling and stuff like that. So that's really that's the bulk of what's holding us up right now. So what do we end up actually building? We did, basically the design philosophy that we went for was pretty much share nothing. So we have 4 regions that we're active in, 2 in the US, 1 in Amsterdam, and 1 in Singapore. The idea being that we didn't want to have an outage in like a data center or something like that take down another one of the regions. So pretty much every one of those is a totally separate OpenStack install. All the VMs are on local storage, so there's no shared storage to have like a common fault domain there. We use what I call simple networking. We weren't super comfortable with overlays due to some experience that we had before that. So we really try to use the network that's in place at the data center and not try to virtualize that. We're going for not having to do live migration, so we really targeted creating a cloud more cattle friendly than pet friendly. So we created multiple availability zones to have applications stripe across availability zones, and use that as a fault, like doing failure domains for that instead of trying to keep single VMs alive forever and ever. Right now, scale-wise, we're thousands of compute nodes, over 100,000 cores, tens of thousands of VMs.
All right, so what we want to focus on today is this notion of accidental architecture. This is something I think maybe Chris coined it, I'm not sure where it comes from, but this idea of what you end up with that you didn't really intend on, you didn't really want. So we found that these kind of fit into about 3 different categories. We're going to kind of step through each one of these, but the first being product, so the way you define what your cloud is going to be, what your interface to your customers or end users is going to be. Infrastructure and scaling, this is more of the technical pieces, all the deep configuration, the way you architect the cloud. And then finally, management around how you actually manage this thing on a daily basis and how you keep it going into the future. So we'll start out with the product side. And the first thing that we wanted to call out around prioritizing your cloud is this need to have a chargeback or showback mechanism. So in a lot of cases for private clouds where you're just running infrastructure for your company, your internal organization, it's very easy to go the route of saying, well, it's just internal. We don't really need to do any billing. We don't need to do any accounting here because we're all on the same team. We're all using this. We're all in this together. But what happens is to your end users, a private cloud with no billing that's essentially free and is no cost just looks like totally free, and they can just go totally wild with it. So we know, of course, from economics, if you have something that's free, a good that's free, the demand for it's going to be very high, which is going to lead to overconsumption, right? So we're all familiar with the traffic jam analogy, right? A public good that anybody can use for no cost, more people than it can really handle use it, and then the performance is degraded for everyone there. So this is one area that we really ran into. I mean, we were definitely in this situation where we would just give large quotas out to everybody. People would go nuts because there was really no consequences to them, and they didn't realize how they were impacting the experience for everybody else. So we would run into situations where we didn't have slots to fit our larger instance types. We would run out of capacity in certain zones in the data center, and then of course that affects the other products, the other teams that are trying to use this thing for their actual products, because they're being squeezed out by other folks that were just using a lot of capacity for dev and test type purposes.
So I guess one of the other big things is really having a cohesive vision for what you're going to apply to your end users. And I know there's a lot of text up on the slides and a lot of points there, but basically the gist of it is document what you're actually providing. So document your SLAs, patching policy, set expectations with your end users, because a lot of the trouble that we had is people just assuming that things worked a certain way, and without a document that actually told them how things were supposed to work and kind of what the expectations were, and kind of some example deployments and architectures to deploy on top of the cloud, they kind of started just moving what they used to do to the cloud, and then they'd run into a couple speed humps when there were some fundamental shifts that we did in how things used to work and how the new stuff at GoDaddy was being built out. Another big one that is integrations with legacy applications. So I know quite a few people here are going to have some sort of old CMDB system or something that's stuck around before the cloud was there, and trying to figure out how to get OpenStack's view of the world into your corporate view of the world. That really needs to have quite a bit of thought follow through, because you end up with having basically multiple caches, and trying to keep the CMDB system, your company's CMDB system, up to date with OpenStack is it's not a fun challenge to kind of do. So basically, if you don't have the documented or the vision actually documented, I'd highly suggest that you go through and document it and put things down on paper. But more importantly than that is actually also document how the procedure to actually get that vision changed, because a lot of the vision drives technical requirements. And so a simple change, like if we built a cloud where we didn't really expect to have live migration, and now all of a sudden we need to provide a very high SLA to our end users, where live migration is something that we'd look to try to increase the SLA availability of VMs, that could be a significant impact depending on how we deployed our architecture to begin with. Like our live migration targets might be quite small due to network architecture or something like that.
All right, so how do you avoid these product issues? We've got a few suggestions that I think are pretty good, but along the lines of Chris's points, along the having a cohesive vision, you've just got to manage the expectations for what you're actually going to do, and then do what you say you're going to do, so that you're, both for your team, the team running the cloud, as well as the end users, are on the same page as far as what to expect, so there's no surprises later. Again, the showback or the controls around quota, very important. And then there's a lot of education that needs to happen. So, we're all very familiar with the cloud model and how to architect for the cloud, and the pets versus cattle. We're all familiar with these things, but not everybody is to that point yet. So you've got to do some coaching. You've got to do some helping of the other teams that maybe are not quite to that point yet, and help them understand this new way of thinking and why it really is a lot better. Some things you can do to help with that, just good documentation, like everybody always says, much more easier said than done. Sample code to help folks get started for hitting the APIs. Maybe find a team that's on their way to cloud readiness or already has some experience using cloud infrastructure. They can be an early adopter for you and give you good feedback around, hey, we thought this was going to work a certain way. It didn't. Again, it helps you kind of tailor those expectations and get those docs out in a way that's helpful for everybody. And then just be prepared to do that ongoing guidance as you go through this journey and folks are onboarding, offboarding the cloud. Just be available to help coach folks through that. So those are the product pieces. Now we'll get into some more of the technical details specific to decisions that we had made early on. And the first one that we want to start with is Sales V1. This is always a fun story, but we knew very early on that we were going to grow fast. We knew that the company was going in a direction that was going to require a lot of cloud capacity. We knew this OpenStack everywhere, OpenStack first initiative was going to be coming down the road. And we had heard about some challenges that other large clouds had with scaling Nova. So we decided to go with the Sales V1, which was sort of this unofficial out-of-tree thing that was put together over a weekend. We knew that by doing it earlier on, that would be easier than getting to down the road where we couldn't scale anymore and then having to do it as a fire drill. So we specifically decided to get the patches merged in, get everything put together earlier on before we were at a huge scale so that we wouldn't have to do that fire drill. We knew we were going to be taking on this ongoing debt to continue forward porting these patches. We owe a lot of debt to Sam at Nectar, of course, because we are able to actually steal most of that from him, so we definitely appreciate the work that he does there. And at the time, that was kind of the beginnings of the Sales V1, V2 talk, and that was coming down the road. Of course, these things never come as quickly as we hope, but we knew there would be an end game there. I did a talk at Vancouver about how we did that transition kind of on the fly. So if you're interested in that, there's a link there. So in retrospective, was this a good thing or a bad thing? Well, it was good because it did help us to scale, right? It did help us to get past some of those limitations that we knew that we would hit. We gained a lot of expertise with Nova. Of course, weaving in these patches that come from out of tree really gets you in the details of everything. And it helped us gain a lot of street cred with the larger community, right? Which is helpful. We all know that's good. This was around the time that the large deployment group was starting up, so we kind of got in good with those folks. And those relationships with the larger deployers, the Nova team, have paid dividends down the road when we've got issues or we have ideas about things. So those are all great. But on the not so good side, we were able to scale Nova out, but there's no similar cells type scaling for Neutron, which has turned out to be a little more of a bottleneck for us than Nova has. The patches continue to get more and more difficult the farther down the road we get, especially now where it's being encompassed by a lot of the V2 code. This stuff isn't necessary. You can't really run it together, right? So it's more and more difficult, and we spend a lot of time getting those patches in line with each new version, and that's really the number one blocker that we have in upgrading to newer versions of Nova is just the amount of effort that it takes to get those patches in there. We're on a non-standard config, of course. It's off the reservation. It's not official. We can't just pull down the direct releases and run them directly because we need those special patches. V2 has taken longer than we hoped or expected, so we've had to kick this can down the road farther. And it's a little unclear how the migration to V2 is going to go. I'm sure we'll collectively figure that out, but it's going to be something that we need to think about. So 2020 hindsight, I think this is something that we maybe regret a little bit. I think we would have been better off if we'd focused on scaling Rabbit, where that's really where these bottlenecks come into play, not necessarily inside Nova itself. So we probably could have focused more on that and been to the same scale that we're at today. We had some pretty big aspirations about scale. We thought we were going to be very large, which I think were realistic at the time. But just the way things go, products get canceled or aren't as large as we expect. And I think we're not really to that hyperscale level where this is really a requirement. And then of course, porting those patches forward is a huge blocker, and it would be nice to be in a universe where we didn't have to do that on every upgrade.
All right, so we run, I see it on the mailing list, it referred to a collapsed architecture. So basically all that means is most of the APIs run on a central set of servers. So we call those our map servers or our main API servers. It's got Keystone, Glance, Sender, Nova, Neutron. Most of the RPC workers are for Nova are on there too. Except for Glance. We put Glance down like next to the hypervisors to make it so where snapshots happen, that transfer happens close to the hypervisor, and then Glance backcalls to, like, we use Ceph object store, so Rados gateway. When we first proof of concept did this, the load was pretty small, so having a dedicated piece of hardware for each service was pretty overkill. So I mean, it made a lot of sense. You get 3 servers, have a little cluster on there, run everything that you can, active, co-locate RabbitMQ on there. Later on, when we went to Cells v1, we created what we call a Cell API server. So that's where a lot of the Nova stuff works. There's a full Nova install on the lower cell. And very little of the actual Nova stuff happens at the top level cell. A lot of the main body of it works at the lower level cell, but that's for Cells v1 is quite different under Cells v2. So if you're new to Cells, don't expect it to work the same way. So retrospective on it. For us, it was pretty simple architecture. Like I said, minimal hardware. It's easy for network ACLs because everything's running on the same box. So there's no firewalls or stuff like that you have to get opened up with the networking team. And it's super fast to get it up and running. But problem is you have a failure and it has a pretty large impact. So you lose one of those servers. RabbitMQ clustering over the years has gotten better, but you can still have some problems, especially now when you get resource contention. So we have some of those processes can be running for quite some time, and they get some of the Python processes, we can see a couple gigs of memory being consumed by a worker, and then that starts conflicting with RabbitMQ. And then sooner than later, we've seen 5 or 6 gigs of memory just disappear in 5 minutes, and OOM killers in there going nuts on some services. So basically the failure impact is pretty big when you start running an architecture like that. And the biggest problem that we had was single API endpoints. So when we wanted to do a maintenance, the APIs that we would hit to try to see if everything was working after a maintenance is the same APIs that our customer hits. So in the Keystone catalog, pretty much the public, the admin, and the internal were all the same APIs. For maintenance, that makes it quite difficult to kind of shut off access to the cloud for your end users, so you can actually do some quality assurance after an upgrade or something like that. So 2020 hindsight on that, it's proof of concept. I think we probably ignored it a little bit too long. We were quite busy unloading a couple more servers, and it should be pretty easy to scale out. So what we'd really like to do is move to a model where we have a set of servers that we just run for the public API. So end users actually just consume that API directly. So we can actually have an easy on-off switch for our end users during maintenance. It'll also take some of the API queries and some load off the main API servers, but then also adding just a couple more servers into the cluster. We moved RabbitMQ off onto its own dedicated set of servers, and that really helped from a load performance and kind of stability of the system, since Rabbit is still kind of a mythical beast to really run it and keep up. So right now we're actively working on implementing the architecture more to the right. So the other thing, we have a kind of a special Neutron architecture. The biggest problem that we had with Neutron when we first started using OpenStack is it had an assumption about layer 2, that a network is defined as a layer 2 network, and that layer 2 is available anywhere. Well, our data center networks are actually a layer 3 folded cloth design. So basically, our layer 2 stops at the leafs. So each one of those leafs up there, that's basically a top of rack switch, so a cabinet, and so layer 2 only exists there. We're pretty uncomfortable with doing overlays, so we wanted to stick with using the network and having the network do like the gateway and the routing and the stuff like that, and just basically our end users didn't necessarily care about the advanced features of Neutron, so they didn't want to be able to build. They didn't want to like build a custom private network and have like attach it to a provider network and all that other stuff. They really we have network availability zones that for us is a collection of layer 2 domains that have certain network policies on it, and that all they really cared is that they could boot a VM. It had an IP that worked in the expected target network zone that they wanted. So in order to do that, we pretty much had to overload availability zones in order to provide the network target, because Neutron didn't have a way of basically saying these collection of layer 2 networks collectively make up this layer 3 network. So we did that using availability zones. So if you wanted to go into dev, there's a dev availability zone, and you could choose that one, which puts you into the dev network. And we had to do some custom network scheduling inside Nova to basically query when you got placed on a host. We had, in host aggregates, we said what networks were available to that set of hosts. And then it would go query Neutron to figure out which networks had IPs available, and then we'd just select one we just return. So we'd actually modify the request as if you had passed -- net. And that's important because basically without that work, for our end users, all of our stuff is provider networks, so we'd have 20, 30, 40 networks available to them. They would have had to have guessed which compute node they ended up on if they were doing it the traditional way of just selecting that network, and then they'd have to luckily choose a host that happened to be, or they would have luckily choose the network when they booted their host, because they didn't know where they were going to end up, and they don't really have a way of targeting that unless we did a rack for an availability zone per rack. We also, in this network, so even though layer 2 is stuck at there, so like the VM's fixed IPs are stuck, what we can do is take another IP and pretty much route it anywhere in that. So we do floating IPs by doing route injection into the network. So if people need a persistent IP, or if they need to fail over an IP between two sets of VMs, it can be anywhere in the network, and we can move that IP just to another node within usually a couple microseconds, sometimes up to a couple seconds, depending on some other conditions. So kind of retrospective, for us, it was good because our VMs work exactly the same as our bare metal and our new infrastructure. For us, it was easy because I'd say it's pretty simple. For end users, it's definitely simple because eventually Nova came out with that Get Me a Network spec, which kind of does the same thing. Not the same thing, but it gave the same illusion to the end users of just like, all I care is booting a VM with a network. I don't really want to set up all the Neutron stuff. It's pretty easy on our end users, and from that, we actually we upstreamed the network IP usages API in Neutron, so now you guys can query the capacity of your networks and get that information. And then the other thing that came out of it is we worked with some of the other large deployment team. We all kind of run similar data center networks, and so we came up with we called it the segmented network spec, and that actually turned into the routed network spec. So Neutron now has an object that you can say you can define a layer 3 network that's made of multiple segments, and it will start handling that stuff correctly. And in the latest version of Pike, okay, you can actually start doing the scheduling stuff, and they will do the correct placement and everything like that. So this stuff should all work without any patches for us when we get to the latest version. The only bad thing is, for right now, for us on our current version, it's kind of a snowflake. And our end users still had some expectations about layer 2 adjacency. So there's some people who wanted to do like keep alive D failures using GARP. That doesn't work on our network. That doesn't work on our bare metal network either. But that used to work in our old network design, and so there's some people who are trying to figure out how to do that. It's pretty easy. You just change keep alive D to not do multicast, and then they run a script now that calls into Neutron to move the IP instead of just trying to fail over in GARP. It's a little difficult for adding, we're working on getting LBAS v2. It's a little difficult for that because they still have some of those fundamental assumptions about doing floating IP failover and having everything on the same network. And the migration to Neutron segmented networks, we have to figure out how to take what we already have and kind of re-bring it back into the segmented network. So we have to create that top level layer 3 network and figure out how to move all the stuff in so it's like appropriate in the database. And then we also have to now get our end users to start passing the -net flag. Since now they can use, if they want to go into production, now they can do -net prod instead of doing just the prod availability zone for network selection. So 2020 hindsight, it works pretty well. The patches are pretty much limited to the Nova side and pretty small. So it wasn't too bad. The community got an IP usages spec out of it, so you guys can actually monitor the IP capacity of your cloud. And we got the segmented network support or routed network support into Neutron rather, and there's quite a few other people who had the same problem. So I think it worked out well.
Okay, so for our final trick, we're going to talk about some config management stuff. We are a big Puppet shop, and the idea at the beginning was to use Puppet as a single source of truth for all configuration things inside the cloud. We use Puppet extensively throughout the company. We already have like the CI pipelines in place and the code reviews. We're very familiar with how all that works. So it just made a lot of sense to try to continue to go that direction with OpenStack. We do use the OpenStack Puppet modules to manage all the services. We make pretty extensive use of the API providers inside those modules to manage things inside the API, so availability zones, networks, et cetera, those types of things. Good and bad here, you know, a single source of truth is what we all want, and in theory, this is what it was going to be, not necessarily reality. Puppet's really good for bootstrapping new servers, so it's super great for bringing on large amounts of new compute capacity where you've got a whole rack of servers you've got to lay down all the packages and config on. So it's super great for that. Puppet has a no-op mode, which is very helpful to understand, you know, if I were to run this for real, what is it going to do? So that provides kind of a sanity check review step there. On the bad side, a lot of this isn't really as great in reality as we might think. So in truth, we've got state in several different places. So we've got some stuff in Puppet. We've got a large amount of it in the Hyper files that, of course, go along with Puppet. And then there's the state inside the OpenStack APIs, which is really the real source of truth for that stuff. And if we're honest, we're still managing some things manually, particularly like roles and grants. That stuff isn't wrapped around config management yet. We ended up with a lot of duplicated IP objects, so duplicate availability zones, duplicate Neutron networks, because if the API call to list the existing ones didn't return back to Puppet, it thinks it needs to create it, so it will go create a duplicate. I think the biggest issue that we've got is the omnibus deployments. Puppet likes to do all the things. It's kind of difficult to target with that and say, I just want to apply this config change to Nova, or I just want to upgrade this one OVS agent package. It's very difficult to do that. No-op mode is not not always truthful, right? So running things in test mode doesn't always match what happens out in the real world when you run it for real. There's no like built-in thing with Puppet to manage a catalog of nodes out there, so we would end up with orphaned or forgotten servers if somebody had forgotten to add the new servers into the Ansible host file, for example. And of course, all this means that orchestrating anything in any intelligent way is pretty difficult. So in hindsight, this is another one I think we would have been better off approaching it a different way. We had a lot of unintended consequences here. One memorable one, not in a good way, but Puppet run and, oh, happens to be a new version of RabbitMQ server in the Yum repo, so I'm going to go upgrade Rabbit on this one box for you. Well, thank you very much, not really what I wanted, but things like that you don't expect to have happen. It's not really a single source of truth, like I've said. We can't do those targeted deployments that is really critical, especially with that collapsed architecture. We should have just used Puppet for the bootstrapping of servers. That's really where we get efficiency gains out of it, and then we should have looked at other tools to do the orchestration. So now what we're doing is using the OpenStack Ansible and Kula containerized services to isolate some of these things and be able to do more targeted orchestration. Okay, so what are some ways that you can avoid all this stuff in your life, right? Think about your future self. And by that I mean, try to actually quantify the technical debt that you're taking on. So it's very easy to just say, oh, we'll just put this in place for right now. It's not really how we should do it, but we'll fix it later, right? And that's fine. We all need to do things like that. We can't do everything 100% perfectly at the beginning. But if you need to do that, at least have a specific plan and a timeline for how you're going to get yourself out of that hole. Because if you don't, then it will just fester in the backlog and just stay there forever, and you'll never get out. I mean, I think we all kind of know this intuitively. But if you can just give it a little more thought on that front end and be more explicit with yourself on planning to get out of it, I think that can help with a lot of heartache. Think about your scale pretty specifically as well. Underestimating that or overestimating it can be just as bad as underestimating it. So the example for us with the cells v1 decision, I think if we'd known then the scale we're at today, we probably would have approached it a little bit easier because we would have seen that we're not at this ultra hyper scale. And then we always say this, but it's, again, more difficult to do than it sounds, but just automate everything as much as you can, or at least get it into a state that it can be easily automatable through an API or a sane command line set, so that you can do that in the future and make your life easier, not just doing manual things all the time. And then keep everything as simple as possible. This kind of goes without saying too, but it's easy to forget this. There's a saying that says the perfect architecture is not when nothing else can be added, but it's when nothing else can be removed. And it's easy to overcomplicate things sometimes. When we were working on this presentation, there was a report that came out. It's called the Stella report. It's a very interesting read. I'd encourage you to take a look at it. But there's this notion of dark debt that came out of that report, and it's this idea that there's technical debt that's sort of known, and you understand that it's there, you know it needs to be fixed. But dark debt is what comes from running these very complicated systems that have all these different working pieces that need to communicate and work together. And there's funny little failures and different things that happen that it's impossible to know about ahead of time. It's impossible for us to fully conceptualize these whole systems in our head. So another quote that I thought was pretty interesting is the second one, where we shouldn't really be surprised when these things break, right? They're so complicated, they should really be breaking all the time. What we should be is surprised when they're actually working, because it's just they're so complicated. It's just amazing that they even work. So keep things as simple as possible. And then kind of related to that is just spread as much of the knowledge around as you can. It's very easy for us to get siloed and to have subject matter experts on each of these different pieces. The problem is that it's impossible for anybody to completely understand the inner workings of these systems all at once. A couple of other good quotes from that report. as things get more and more complicated, like our brains are just not able to handle all that and completely understand the entire thing at once. So one of the things that often comes up in retrospectives is folks will say, after they've kind of delved into the problem and understood what broke, is folks will say, oh, I didn't realize it worked that way. I didn't know that's how it was. I thought we fixed that. I thought didn't know we changed that. And these are all related to how complicated the systems are and the amount of knowledge that each of us have that others don't. So as much as you can, do your lunch and learns or, just different things like that to try to get the knowledge into other people's heads, the better off you're going to be, because things will still break, things will still not go how you want. You'll still end up with some accidental architecture, but at least then you can kind of combine your heads a little better to figure out what to do to get out of it, what to do to fix it, and be in a better place than you are today. So those are our suggestions. There was also another talk this morning, I think, titled Battle Scars, Lessons Learned from Running OpenStack Clouds. That was a pretty good one. A lot of similar takeaways, independent from what we had found. So I thought that was interesting that we kind of had some of the same suggestions. But any questions or any other ideas that other folks have from your experience that you might want to share that might be helpful to the room? Nobody? Does this make sense? Good. Thumbs up. Okay. Other questions? Anything?
Well,
I made a lot of the same mistakes, so.
Yeah, that's what you find. Yeah, a lot of people that you talk to have a very similar journey. It's interesting.
yes.
We already 3 years.
Yeah.
We were making the mistakes 3 years ago, so.
They were good ideas back then.
Good ideas back then, yeah. Okay, well, thank you. We'll be around for a few more minutes if there's anything else. Appreciate your time.